Tau Boötis B, or more precisely Tau Boötis Ab, is an extrasolar planet approximately 51 light-years away around the primary star of the Tau Boötis system in the constellation of Boötes. The planet's existence being announced in 1996 by Geoffrey, Marcy and R.Paul Butler. Tau Boötis was one of the first stars confirmed to have planets orbiting it. On the 16th of December 1999, the planet was dubbed the Millennium Planet because the planet was then thought to be the first extrasolar planet to be discovered visually. The planet and its host star is one of the planetary systems selected by the International Astronomical Union as part of the public process for giving proper names to exoplanets and the host star. The process involved public nomination and voting for the new names, and the RU planned to announce the new names in mid-December 2015. However, the IAU annulled the vote as the winning name was judged not to conform with the IAU rules for naming exoplanets. Discovery. Discovered in 1996, the planet is one of the first extrasolar planets found. It was discovered orbiting the star Tau by Paul Butler and Geoffrey Marcy using the highly successful radial velocity method. Since the star is visually bright and the planet is massive, it produces a very strong velocity signal of 469 ±5 meters per second, which was quickly confirmed by Michel Maire and Didier Queloz from data collected over 15 years. It was later confirmed also by the AFOE Planet Search Team. Orbit and mass. Tau Boötis B is rather massive, with a minimum mass over 4 times that of Jupiter. It orbits the star in a so-called torch orbit at a distance from the star less than 1/7 that of Mercury's from the Sun. One orbital revolution takes only 3 days 7.5 hours to complete. Because Tau is hotter and larger than the Sun and the planet's orbit is so low, it is assumed to be hot. Assuming the planet is perfectly gray with no greenhouse tidal effects and a bond albedo of 0.1, the temperature would be close to 1600 K. Although it has not been detected directly, it is certain that the planet is a gas giant. As Tau Boötis B is more massive than most known hot Jupiters, it was speculated that it was originally a brown dwarf, a failed star, which could have lost most of its atmosphere from the heat of its larger companion star. However, this seems very unlikely. Still, such a process has actually been detected on the famous transients planet HD 209,458b. In December 1999, a group led by A.C. Cameron had announced that they had detected reflected light from the planet. They calculated that the orbit of the planet has an inclination of 29 degrees and thus the absolute mass of the planet would be about 8.5 times that of Jupiter. They also suggested that the planet is blue in color. Unfortunately, their observations could not be confirmed and were later proved to be spurious. A better estimate came from the assumption of tidal lock with the star, which rotates at 40 degrees, fixing the planet's mass between 6 and 7 Jupiter masses. In 2007, magnetic field detection confirmed this estimate. In 2012, 2 teams independently distinguished the radial velocity of the planet from the radial velocity of the star by observing the shifting of the spectral lines of carbon monoxide. This enabled calculation of the inclination of the planet's orbit and hence the planet's mass. One team found an inclination of 44.5 ±1.5 degrees and a mass of 5.95 ±0.28 megajoules. The other team found an inclination of 47 to 6 + 7 and a mass of 5.6 ± 0.7 megajoules. Characteristics. The temperature of Tau Boötis B probably inflates its radius higher than Jupiter's. Since no reflected light has been detected, the planet's albedo must be less than 0.37. At 1600 K, it is supposed to be hotter than HD 209,458 b and possibly even HD 149,026 b. Tau Boötis B's predicted Sudarsky class is V, which is supposed to yield a highly reflective albedo of 0.55. It has been a candidate for near-infrared characterization. With the VLTI spectro-imager. When its atmosphere was measured in 2011, the new observations indicated an atmosphere with a temperature that falls higher up. This result is the exact opposite of the temperature inversion, an increase in temperature with height, found for other hot Jupiter exoplanets. In 2014, direct detection of water vapor in atmosphere of the planet was announced.